So today classes we are going to discuss about the NACA MapReduce programming. So last classes we discussed about the meaning of the NACA. What is the NACA? That NACA is nothing but it's a kind of a software programming tools, and it's a framework which is basically used to develop a distributed application, right? So if you want to develop a distributed applications in the cloud, we have to use the NACA. The NACA is just like a middleware which help the clients to develop a distributed applications, right? So last classes we had gone through the brief introductions about the NACA. So today we will discuss in details about the NACA MapReduce programming, and before going to this topic, let me address some of the important architecture of the NACA, which is very essential to understand this NACA MapReduce programming. So you see, this is the architecture of the NACA we are having. This NACA is nothing but it's a kind of middleware which can provide services to develop a distributed application, and it is one of the implementation model used for the PaaS. The PaaS is nothing but it is called as platform as a services. So if the client want to develop any kind of applications like distributed applications, so they can use this NACA. NACA will going to provide a platform to develop and distribute applications on the cloud environment. So here, this if you see this kind of architectures, we have different services are given here. So this is for the client people. So I suppose you are the client. The clients will have various client libraries, and they can have different programming models, like they can have task models, thread models, and MapReduce models. So you can also implement the MapReduce task. So last class we discussed how the MapReduce programs are working, and for that we are going to use MapReduce task operations is used to run the MapReduce application. So this client libraries will going to provide you different kind of services for the clients, like task models. We can have a task, and these task models will going to divide these tasks into a number of splits. They will have thread models and also MapReduce models. So this NACA is also can be used to implement the MapReduce programming. So this is for the client libraries. Then we have the two important containers we are going basically using the NACA. One is called as master containers, because master container is the one who can control the workers, who can control you can say the task takers. And these master containers will provide different types of services such as scheduling services, accounting services, reporting services, reservation, provisioning, and storage. So these are the basic services what is being provided by the master containers, like scheduling, how to schedule these jobs. If the jobs are coming into queues, then how we can schedule them. Then what is accountability, you can also can be tracked by the master containers. Then reportings, then the result of execution results. Then this is also resource provisioning. Then you have storage, means the storage of the resources. All this can be managed by whom? Managed by the master containers. So these are the important services we can list out for the master containers. And these are called as worker containers, because our worker containers are those containers who can contribute the execution services. The execution services can be happens only through the worker containers. So we may have different worker containers are there, and these worker containers can provide different types of services, like it can execute the task, it can execute the jobs which can given by the clients, and also it can also have monitoring the allocation of the resources, how many resources are allocated to each workers. That can be also monitored by the worker containers in the worker containers. So these worker containers will have different types, and number of worker containers will be there, which can impart the services of execution services. So basically we are focusing about two types of services. That is, one is called as scheduling services, and second is going to call as execution services. So these scheduling services will be taken care by the master containers, whereas the execution services is taken care by the worker containers. Apart from that, we also need some kind of distributed file system. The distributed file system is also required to provide a implementation of MapReduce programming models through the NACA. and this is the management studio. So as a client, we can access various services, right? So these are management studio which can manage this different types of services. It can monitor the different types of services, whether these different types of services has been properly executed or not executed, has been properly scheduled or not scheduled. So this can be also managed by the management studio. So if you see this, if you look this kind of architecture of NACA, we can come to one conclusion that it can provide two important services. One is called as scheduling services, which can be taken care by the master containers, and second is going to call it execution services, which can take care by the working containers. And also that apart from that, it can provide a very great libraries or a massive libraries for the client. The client can have a API to through that they can develop a different distributed applications. Now with this clear architecture of NACA, let us discuss about the NACA MapReduce programming models. Now this is NACA MapReduce programming models here. If you see this diagram, these diagrams will talk about the infrastructure which can be provided by the NACA for the MapReduce application. So what are the infrastructures can be provided by the NACA for the implementation of MapReduce applications? So this architecture describes in a very clear way. So this is nothing but this is client machines we're having. This is client machines we're having, and the clients will have a data files, right? The clients have the data files, and clients wants to execute the MapReduce applications. So if they have the MapReduce, jobs are there with them, and they want to execute these MapReduce jobs. So these client machines, what they will have the input data files will be there with the client machines, and they want to perform a MapReduce application task. It means they want to perform the mappers and reducer task. So what will happen is that this whatever the data files the clients will having, it will be split into it have the various splits, because as you know that concept of MapReduce, if you have the big file, that big file must be split into a number of splits. It means we are just crunching the data, right? So we are splitting the large file into small pieces. The same way, if you have data files with the client data files, what happens? It's going to be split into a number of splits. So this indicate that we have a number of splits we are having. See, as per this example is concerned, it has the totally 5 splits are given. That's split 0 up to split 4. Now this will be this can be this input file or this input split must be processed, and for the processing we are using the MapReduce execution services. So already I told that two types of services that NACA will provide in the terms of MapReduce implementation. One is called as MapReduce scheduling services, and second is going to call as MapReduce execution services. So here the scheduling services will be take place, that which input file has to be processed. By processing, what kind of services we can provide for that clients. And later on what happens, we are going for execution of the services. For the execution of the services, we require the workers. So these are kind of MapReduce execution services we have. This is also called as nothing but we have the workers node, and these worker nodes are supposed to execute the task or job submitted by the clients. So here so after execution of this task, we are going to get results. Say results may be the output file 0 and output file 1. So this has to be submitted to the client. Okay, so it means this will provide a very good platform for the implementation of the MapReduce programming models in the cloud environment, that the clients will going to submit the jobs. That jobs has to be split into a number of pieces, which is called as a number of splits. So one job may have 5 splits. Then if we have 5 splits, then we have a 5 mappers. If the job have 6 splits, then we have a 6 mappers. So depending upon number of splits, we can decide the number of mappers, and that has to be given to the MapReduce execution services. The MapReduce execution services will have the worker containers, so they are taking the charge of execution. So they will execute the files, that they will execute the splits, and they will come out with the results, right? And later on this result has been given back to the client machines. So in this way, what happens, this MapReduce executions will be taking place. This will indicate the distributed file system implementation, because as you know that you are working in a distributed environment, that the splits, see, if you are taking the large number of files, that files will be divided into a number of pieces, and each and every split has been given to each and every machine. Suppose if you have 5 splits, then you have to give it to the 5 machines. So what happens, we are doing parallel processing. So this is called as nothing but it's working in a distributed file system environment, that we are running a different clusters in a we are running a different clusters, and every clusters are going to work in a parallel processing. So if you have more number of files, we can add more number of nodes depending upon the requirements. So that's why the scalability is more concerned here. So we are also we are looking towards the scalability of horizontal scalability, where we can have the large data sets divided into small pieces, and each and every pieces should given to the different nodes, and they will going to run it through the process of parallel processing. So that's what happening here also. So that's why we are using the distributed file system implementation here, and this will going to be taken care by the different execution services. That's the worker nodes here. So this is a simplest Aneka MapReduce programming models, where we can see that we have the client machines. The client machines will have the data files. Data files are divided into a number of splits. Number of splits are given to the execution services. So they are going to execute that. They are going to execute this task, and later on what happens after execution has been completed, the task is, it means the output is submitted to the client back. In this way, what happens? This Aneka MapReduce programming models are working for the client machine. So the clients can easily deploy distributed applications on the cloud environment through this Aneka middleware. Now coming to this, it means this runtime support is composed of two main elements. So here, what are the two elements we are going to focus on it? The first element is called as the MapReduce scheduling services, which plays the role of master process in the Google and Hadoop implementation. So all of we know that before coming to Hadoop distributed file system, we have GFS. What is GFS? Google File System. So who has given the reference model for this kind of MapReduce? You can say the Googles. And then Hadoop came into existence. The Hadoops will going to provide the large processing of data with the help of MapReduce programming models, and Hadoop will provide to store a bulk amount of data, that is called as big data, with the help of Hadoop distributed file systems. So this kind of two important elements are basically used to execute the large number of tasks, or to execute the MapReduce applications. The first one is already we are talking about is MapReduce scheduling services, right, which plays the role of the master process in the Google and Hadoop implementation. So who will take care of the scheduling services? Of course, the master process. Already we told in the last classes that reference architectures. The reference architectures will be based on the masters and slave relationship, right? So we have a master, and then we have the slaves will be there. So this is called as what kind of relationship? It is called as the master slave relationships. So here basically what happens, the masters will have control over the slaves. So whatever the instruction the masters are going to pass, the same instruction what should be executed by the slave itself. So here who will going to take care of the scheduling task? The scheduling task is basically, or literally you can say, is take care by the master node, and which is take care by the master containers. The master container is the one who will take care of all the scheduling tasks, right? And who will take care of this kind of execution services? The execution services what is we take care by the slave. The slave is the one that is nothing but it's going to call the worker node who will take care of these execution services. So which plays a role of the worker process in the Google and Hadoop implementation. So if you take in the Hadoop implementation, we are using the SDFS, right? Or if you say in the Hadoop implementations, if you are using MapReduce, so this slave is nothing but it is going to call as the worker node, which will take care of the execution services. So whatever the clients are going to submit their job or task, it may be the big task or it may be big task. What happens? This task will be take care by the MapReduce programming models, and MapReduce programming models will be implementing the Aneka with two kind of services. One is MapReduce scheduling services, which can be schedule the different types of tasks which can be given by the clients. So MapReduce scheduling services can be taken care by the master process, or you can say by the mastering containers, whereas the execution services is being taken care by the worker nodes, or it is also called as the slave nodes. So these two important kind of components are plays important or vital roles for the implementation of the MapReduce applications model. Now these are the this will indicate about MapReduce scheduling service architecture. If you see this, that how the schedulings will be taking place and how the schedulers will going to provide services. services, how the schedulings will be taking place in the ANECA, because ANECA is nothing but it's kind of middleware which can provide the services to implement MapReduce applications. So to implement MapReduce applications, we are going to take the help of the ANECA also. So you see here, this MapReduce applications are going to interface with this MapReduce schedulers through the ANECA middleware. So this ANECA middleware is what it is act in between the MapReduce applications and MapReduce schedulers. So in between these MapReduce applications and MapReduce schedulers, what happens? We are going to use what kind of middleware? We are going to use the ANECA middleware. So this ANECA middleware will provide the interface between the MapReduce applications and also the MapReduce schedulers. Now, if you see that this will consist of many components, important components. If you see this architecture, the one important component is what? The MapReduce scheduler services. Second is called as the MapReduce schedulers, and third is called as MapReduce applications. So it have the three important components. One is MapReduce applications, second is MapReduce scheduler services, and third is going to cause MapReduce schedulers. Now, MapReduce scheduler services can provide a different kind of services. So this MapReduce service will provide different kind of queues. They have multiple queues. They will maintain multiple queues. Okay, some of the queues are used to upload the input file. Suppose if we want to upload the input file, input file in a distributed file system, we have to use the upload queue. The upload queue is what it is basically used to upload the input file in distributed file systems. Similarly, these schedulers can provide another kind of queue which is called initialization queue. So before scheduling, we need to initialize. We have to go for the initialization, and for the initialization, what happens? This schedulers can provide the initialization queue, and then it also provide you the MapReduce and schedulers, scheduling the MapReduce task, scheduling the reduced task, right? So this kind of queues can be given by the MapReduce schedulers. And then failure queues. If once you submit some kind of job, and if the job is getting failure, if the job is not submitted successfully, then it's going to say what kind of queues? Failure queue. It go to failure queue. It means this job has been not submitted successfully. So it's going to give an error. So it's going to maintain a queue for failure queue also. How many jobs has not been submitted successfully? How many jobs are still in the queue? So here, this is for that you are going to maintain the failure queue. So failure queue will have a track of the failure of jobs. How many jobs are failed while uploading? So, and then resubmission of the queue. It means we have to resubmit. Once the job is failed, we have chance to resubmission of the same job once again. And reporting queue is going to report the all kind of execution, how many jobs has been executed, how many jobs are successfully executed. So it's going to generate a kind of analysis report that how many jobs are already executed successfully. So this kind of queue who will going to maintain the MapReduce schedulers are going to maintain all this kind of this scheduler queues. So this is also called the scheduler queues. And to run the scheduler queues, you will maintain the thread, because to upload the input files, you need to maintain upload thread. If you want to initialize the queue, you have to maintain the initialize thread. If you want to dispatch the queue to the if I dispatch the job to the workers node, we have to maintain the dispatch thread. And if you want to generate the report, then we have to maintain the report thread. So this is called a threading model. It means we are going to use a multi-threading. Okay. So the multi-threading is what? You are running more than one thread simultaneously here. So one thread is used for upload the queue, other threads used for initialization of the queue, other threads used for the dispatch of the queue, other threads used for the failure of the queue, other threads used for the resubmission of the queues, other threads used for the reporting of the queues. Okay. So this is what happens. The schedulers will play an important roles, because they will maintain this. What is the main task of the schedulers? The main task of the schedulers was to maintain different types of queues, and that queues will going to go on the tracking of the jobs, that when and how the jobs will be submitted, and all the records of the submission of the jobs will be maintained by the MapReduce schedulers, right? And this is being called as what? MapReduce services. And this is important implementation of the ANECA, because ANECA also going to implement the MapReduce models. MapReduce applications can be executed through the ANECA. The ANECA will provide a platform for the execution of the MapReduce task. Now this is going to call as the the executions part. So this is that one you are talking about the map rule schedule services, because the map rule schedulers are placed in very vital roles. And coming to the next slide, we are going to see about the map rules execution services. So so far we concerned that the map rules execution services will be taken care by the worker nodes, whereas the map reduce scheduling services will be taken care by the master nodes or the master process. So generally we are going to use two important processes. The one process is called as the map reduce execution process. Second is going to call as the map reduce scheduling process. The map reduce execution process will be taken care by the worker nodes, whereas map reduce scheduling process will be taken care by the master nodes. So coming to the execution process, coming to the execution services, you see here, this is the map reduce scheduling services is very important. So there should be interface between map reduce scheduling services and to the execution services. So how we are going to make interface between the map reduce scheduling services and to the map reduce execution services? It's only through the ANECA middleware. Again here the ANECA is what act as a middleware which will be act in between this in between the map reduce scheduling services and map reduce execution services to provide a proper interface. And to provide a proper interface between these two types of services, we are using the ANECA middleware. Now, if you come into this ANECA middleware, or you can see the ANECA middleware, which can provide interface between these two services. You see, this is the executor services models we have, right? So, what is executor services will do? It's going to execute your services, going to execute your task. So, once you clients you submit the task is given to the task is submitted, right, and the task is divided into a number of splits. Then each splits are given to the different worker nodes, and the worker nodes are going to execute each the splits. So it means that we are working with a number of the clusters, right? We are working with different machines, working with different nodes. So here this is the executor manager. So the executor manager is the one who can take care of the command queue, job and task information, report thread. So how many jobs and tasks is already being submitted, how many jobs and tasks must be executed, then who can take care of all this kind of information? The executive manager. The executive manager is also talking about command queue. Then because to have a command queue, that how many jobs are being already scheduled by the schedulers, and for that you are going to have all the information on this command queue, and for that you are going to use command thread to run the command queue. Then we have job and task information. So here the information of the particular jobs will be displayed. Then which jobs has to be executed first, which jobs has to be executed second, which jobs has to be executed third. So we are going to maintain the priority scheduling of the jobs. And then we have the report threads. It's once the output has been generated, that report has to be sent back to the clients, right? So for that we are going to maintain the report threads. And this is the sandbox. Why I'm going to call it sandbox? Because each and every workers will going to work on the same way. It means the worker node has to perform these two important operations. So what operation they have to perform? They have to perform two important operations. The one is called as the reducer operations, right? And one is going to call as the mapper operations. So mapper operations will come first. Now after mapper operations, what happens? It is being then you have to perform the reduce operations. So first we have to perform the mapper operations, followed by the reduce operations. So this is who can perform this kind of task, the worker nodes, and for that it's called as map reduce executor can execute the map task. The map reduce executor can execute the reducer task, and they can going to provide you the final outcomes. Okay, so that's why it is going to call as this part is nothing but is part of the worker node, or it's part of the slab node. The slab nodes will maintain two important execution. One execution for the mapper task, and second execution for the reducer task. So already in last class we discussed with an example that how the mapper reducer task will be taking place. So this kind of services is called what services? Map reduce executor services. So this kind of services is already given to you. So up to this class, today we discuss only about the map reduce task. And the next class is going to discuss about the data file formats that is used in the ANECA. Thank you very much.